Okay, so we're continuing with probability, and we're going to go through some more basics about probability. And let me just get our gear together, so to speak. Um, 1 minute. What I'm looking for is my smooth draw, which is right over here. Okay, now we're ready to go. So next thing I need to do is get my pencil. And now we're ready to go. Okay, so here's the deal. We're talking, of course, probability. And I want to start out with the following problem. We talked about sample spaces. So here's the problem I want to start with. And we are talked about throwing two dice on the table. Two dice thrown. Okay. Here is the question. What is the probability of getting a sum of 5? The probability of getting a sum of 5. That is the question. Okay, and we talked about the sample space. We talked about the 36 possibilities that you can have with the sample space. So how do you get a sum of 5? This is what we have this problem up there for. Here we go. You can get a sum of 5 by getting a 1 and a 4. 1 plus 4 is 5. So you win if you get 1 and a 4. If the red is 1 and the blue is 4. That's one situation. You also win if the red is 4 and the blue is 1. The two separate situations. That'll be another way of winning. Okay. Now, how's another way of getting a sum of 5? If you get the red is 2 and the blue is 3. If the red is 3 and the blue is 2. And we've run out of that. Try to match up with let's say a 5. A 5 and a 1 will make a 6. That's too much. That's not a sum of 5. We're only interested in the cases which will give us a sum of 5. A sum of 5 is 1 4 4 1 2 3 3 2, and there is nothing else that you can get that'll produce it. That's it. So what is our sample space? Our sample space are 36 possibilities. 36 possibilities that can happen if you throw two dice on the table. So that's the denominator of the probability. What's the numerator of the probability? The way you win, the things that we're interested in. What are we interested in? We are interested in as follows. Let me get this back. We are interested in these 4 cases: 1 4, 4 1, 2 3, and 3 2. There's a total of 4 cases that we're interested in that makes us win the game, so to speak. And now, 4 out of 36 chances of winning this game, getting a sum of 5. We have to reduce. Whenever you can reduce, you must reduce a fraction. 4 is divisible by 4, you get a 1. 36 is divisible by 4, you get a 9. And there is the final answer to problem number 1. That is the probability of getting a sum of 5 is 1 over 9. Okay, we're going further into probability, and the book calls it addition rules. Right? I'm not too worried about vocabulary, but here it is: addition rules of probability. Addition rules of probability, and let's see how that's phrased. Okay, now. Intro. I've got to give you a little bit of intro before we look at some of the book's problems and some of the stuff that you might get on a test or that you might get in the ALEX, as follows. We've got to talk about playing cards, right? So in case you don't know or you're rusty or whatever, I got to tell you exactly how playing cards work. Okay, so here it is. There's 2 types of red cards. There's the 2 types of red cards. They would be the hearts and the diamonds. And each of both the hearts and the diamonds, they have number cards that go from 1 to 10. So does the diamonds. And then there's picture cards called the jack, the queen, and the king. So the ace doesn't count. The ace will just count as a 1. We're not going to worry about ace over here. That's going to go between 1 and 10. And then the picture cards are jack, queen, and king. So the same exact thing is true of diamonds, of course. The diamonds has the exact same thing, and they both are red. Then there is 2 sets that are black in a deck of cards, right? There's a total of, in a deck of cards, there's a total of 52 cards in all, 52 cards completely. And here's how it breaks down. There's 13 over here. This is a total of 13. This is a total of 13. And now with the black cards, there's the spades and the clubs. And it's the exact same thing. 1 to 10, 3 face cards, jack, queen, and king. And with clubs, exact same thing. 1 to 10, and jack, queen, and king. And there's a 13 and 13. 4 times 13 is the total of 52 cards. So now if you have a problem that involves cards, you know exactly how cards work. Okay, now let's start right away with a problem that involves cards. So I'm going to call it problem number 1. Even though I call that problem number 1, that's okay. We can call this problem number 1 too. Okay, give me a minute as I try to move up the piece of paper. There we go. Back to our piece of paper. And here is the question. This, by the way, is 10.7 in your textbook. When you're trying to look this up, it's 10.7 in your textbook. And it involves homework number 7, I believe. I believe it's homework number 7. I'm not looking at it. Oh, here we go. Yes. And it involves homework number 6 and 7 together. Homework number 6 and 7. And actually, they all belong together. The probability is 6, 7, 8, and 9. I'm trying to get all of those in. 6, 7, 8, and 9, all those topics in between with the next couple of videos. All right, but we're talking about homework 6, 7, 8, and 9 has to do with test number 2. Okay, so let's get to our problem. The problem is as follows. You pick a card randomly. All right, that's how they're going to pick a card randomly. Fine, that's the usual. There's nothing unusual about that. And what's the question? The question is, what's the probability of getting a 4 or a face card? Here's question A. What's the probability of getting a 4 or a face card? A face card. That would be jack, queen, and king. Okay, these are called, let me put that up over here. These are called face cards. All of these are, face cards. Okay, so what's the probability of getting a 4 or a face card? All right, as follows. I'm sorry. I want to start out with an easier question. Oh, I apologize. Hold on a second. I want to start out with a much easier question. Let me go over here. Hold on a second. Get my eraser. Bear with me for a minute. I need the eraser. Okay. Okay. So we've got our eraser, and we have to erase this. I apologize for, or a face card. So now back up here, get my pencil. All right, do we got it? Yeah, I have it. Yeah, no. Let me come up here. 1 second. Get the eraser. Okay, so I got the pencil. Back to the pencil, and I apologize, but we're breaking a card randomly, and I want to start out with an easy question. That was a harder question. What's the probability of getting a 4? Okay, so how many 4s are in this deck? How many 4s are in this deck? There is a 4 of hearts. There's a 4 of diamonds. There's a 4 of spades and a 4 of clubs. So there's 4 of them. There are 4 4s in the deck. How many are total cards in the deck? 52. So here's the probability. We have to reduce it. 4 goes into 4 once and into 52 13 times. Here is the answer. It's a 1 in 13 chance of getting the of picking a 4. That's problem 1A. Okay, problem 1B. What's the probability of getting a face card? Probability of getting a face card. All right, how many face cards are there in the deck? There are 3 of the hearts, 3 of the diamonds, 3 of the spades, and 3 of the clubs. That's a total of 12. So there's 12 out of 52 chance of getting a face card. You reduce that. You divide 12 by 4, you get 3. You divide 52 by 4, you get 13. And that is the probability of getting a face card. Let's go on to the one that I talked about before, 1C. What's the probability of getting a 4 or a face card? Or a face card. All right, so that's where this thing comes in of the addition rules. We are talking about the addition rules. Let's underline that right over here. Addition rules. So we're gonna get you win if you get a 4, and you win if you get a face card. So what's the probability of getting either of those? The probability is as follows. It is 4 out of 52 chances of getting a 4, and there is a 12 out of 52 chances of getting a face card. So you have a total of 16 out of 52 chances of getting either a 4 or a face card. You win if you get a 4, you win if you get a face card. And what is that reduced to? That is equal to 16 divided by 4 is 4. 52 divided by 4 is 13. And therefore, the answer is 4 out of 13. Now here comes the key. That's the answer to C. Here comes the key. Right over here. Here's the formula. The probability of A union B. A is getting a 4. Let me come over here. I'm sorry, right over here. A equals picking a 4. Picking a 4. And B is picking a face card. Okay. What's the probability of getting either picking a 4 or, there's that union side, or picking a face card? A is picking a 4, B is picking a face card. Probability of A, it's equal to the probability of A plus the probability of B. The probability of A is right over here, and the probability of B is over here. Add them together, and that's how you get your answer. And the reason why this is true, is because our case 1 were mutually exclusive events. If you pick a number, 4, you can't be picking a face card. If you are picking a face card, you can't be picking a 4. Therefore, picking a 4 and picking a face card are mutually exclusive events. And the formula for mutually exclusive events is right over here. That is a key point in addition rules of probability. The next video is going to deal with further addition rules of probability where they're not mutually exclusive events. But this point is being made right over here, and this is a very good example that tells you what's the probability of a 4 or a face card. You add the two probabilities together, you get 16 over 52. You get 16 over 52, and you reduce it, and you have your answer 4 over 13. So that ends this video.